Okay, so let's begin. So this is basically a boiler smart switch for Google, Amazon, whatever. It stopped working. So this is the electronics. I will zoom in a second. I've disconnected the cover, the touch panel. There is a touch here. Okay, and I've already disconnected the screws, the connection screws between Fasa 0 input and Fasa and 0 output to the boiler. By the way, these switches always need the 0, not just the phase like regular lamp, because you need to supply all the time electricity to the board in order to make it to work. So I suspect that maybe the relay inside are burnt or something like this, because it stopped after just a few uses, and I'm pretty disappointed, and I am a little curious to see what's the electronics inside looks like. So let's begin and disconnect this panel. By the way, I will put a link in the description later. So let's take it apart. So as you can see, hopefully there are connectors between two boards like other kind of smart switches. By the way, this tiny board here is the Wi-Fi. I suspect this is ESP 8266 chip, and what is written later I will check it out. I will try to remember how it is connected, because I see there are 4 wires in this side, but also 4 connection in the other side of the connector, meaning I can flip it. Let's see if I flip it. Yes, it can be connected exactly the other way, and I don't want to do it because I'm not sure. Let's say I am sure that it should be connected this way only. Okay, so hopefully I will remember it. The best thing in such cases is to take a picture, so you won't forget how it was done in the first place. So I will take a picture just to make sure. Okay, so I took a picture. Let's disconnect the board. There are 4 tiny screws. Let's search for the correct screwdriver. This is Phillips, by the way. So let's open it. These are the relay switch, probably. And I'm a little curious to see what's the current that they put to the relays, because it says that this is above 3000 watts. So it requires a relay of more than 15 amps. Probably 15 or 16 amps. Okay, so there it is. So what do we see here? Basically, not much. Okay, so we can see the relays. By the way, they put a thermistor or some kind of temperature meter in order to measure the heat of the relay, which is pretty smart thing to do, because if you have, let's say, a short, so it would be hot very fast and you want to disconnect it. And the relay are 5 volt 16 amps. I'm impressed. What is written is what it should be. By the way, the relay is working, it's doing a click, but it is not outputting the current to the connector. So the next thing to do, of course, is to measure it with a fluke or something and to see that it is connecting the wire. So if you will look at the relay, so it's pretty obvious that it should be connected from here to here and from this side to this side. So let's see if I'm right. Yes, it is written natural 1, live 1, which means the live is the input and the live 1 is the output, also for the natural. By the way, about the circuit, so there is nothing here more than this is, of course, some power supply, which means it's get the power and it is down to the controller to the correct power. I see here probably this is a diode bridge. There are also diodes here, and you need a driver for the relay. Each one is a MOSFET, and you have a tiny diode here. I will zoom a little so you will be able to see it better. Okay, so let's focus to the color. Okay, so we can see here a diode. Each diode is, of course, a protection. The protection is when the relay is disconnected, the coil of the relay is disconnected, then you have the I to the T, you have a slope in the time, so the current is changing fast, so you have a voltage, let's say, jump, and the voltage jump can ruin the MOSFET. It is connected between the source and the drain. So the purpose of this is that when you have the flow of the current, it will be discharge and it will not be high voltage jumps, because the jump will be up to 0.7 volts. This is probably a silicon diode here and here. Also, the diode is not protecting the relay, it is protecting the MOSFET or the bipolarity transistor that is activating the relay. This is the reason why it is done. It's always like this, and here we have the relay and we have a transformator, probably a coil that reduces the 220 volts to a lower voltage, and then it is regulated. Basically this is what it is. And now what I want to do is to test and see if the relays are really not working, and if not, which one is the problem. And this will be done just when I will find my fluke. So looking for my fluke now. Fluke, where are you? Fluke, where are you? I'm sure you were here not long ago, but here it is. Found it. Okay, so I will zoom out a little so that we'll be able to see the fluke. So Sorry about the reflection. So maybe I will put it like this so there will be less reflection to the camera. Now, the way to, by the way, test it is pretty easy. I will now explain what we will do. Of course, I will not activate the circuit. What I will do, I will supply 5 volt directly to the relay, and this can be done easily, and I will explain how to do it. You have the anode and the cathode. Cathode is the minus, the anode is the plus, and you supply exactly the opposite, meaning to the cathode you supply plus 5 volts, and here you supply the GND, and then the relay. You will hear a click. The click is activating the relay, and in this way I am, let's say, going over the circuit and supplying directly the voltage to the relay. So let's do it. We've seen that the relay is 5 volts. We'll go to 1 amp. 1 amp current limit. Now I will try, it's a little tricky to you know, also to connect. Let's first hear the click. I'm sure it will be a click. So again, the plus to the cathode and the minus. I hope you can hear it. So the relay is clicking. Also this one. So there are very good clicks. So let's now try to catch it, and I will put at the same time relay. Okay, and we don't hear a beep of the fluke, which means something is bad. So this relay is doing the click, and you see it's not always transferring the current, so it is broken. Let's go over the other one to see if I have the same phenomena, which is annoying. So this one is working. Again, one relay is working. Only need one to be broken in order not to make it work. I don't believe it. Okay. I can see something that's suspicious very much. It looks like I have a cold soldering. Cold soldering meaning that it looks like it is soldered, but it is actually not soldered. So I will look with a magnifying glass, and I will try to see. What do I see? Yes, it really looks open. I don't believe it. I will try to show it through the cam. If this is only the problem, so I'm glad. I will try to show you. I'm not sure if I can show you, but if you will look carefully, here, so soldering not looks well. Let's try to resolder everything and see if the problem is solved. So I have here my Harco 951 soldering station, which is going to work in a second. And of course what I will do here, so of course I will go over all the soldering, because I don't really understand why they put so little amount of soldering paste. So I'm doing here the resolder. Take into account that the current that is transferred through the relay can get to 16 amp, so if the board is a little, it's catching hot, so it can cause soldering to be disconnected and to cause this phenomena that we see. So we're doing the resoldering. Hopefully there will be a... Okay, so I get connected now to the terminals of the board and doing it again, a test. And I'm sure that now it is working. So now let's assemble everything back and pray that it will work, and hopefully we're done. Meaning, although it is a Chinese and I suspect that all the relay will be burned, so it is not. And hopefully now the problem is solved. So now false wire. Now I'm sure that it was connected this way. I took a picture and I don't need the picture. And now we'll connect all these terminal screws. And then we are done. Let's say I'm 99% that I've solved this problem of this smart switch. You can recognize it by the waterfall and the one, by the way it fell and it's a little broke. The plastic here. Hopefully it will work anyway. That's all. Hope that this movie helped you, especially if you met the same problem as I did. So that's all for now, and bye bye.